Bismillahirrahmanirrahim. In this 10th lecture of Real Statistics and Islamic Approach, we are going to argue that statistics and econometrics are based on completely wrong foundations and the whole discipline should be scrapped and rebuilt on new foundations. Now, there is a question of why this is so. Why is it all wrong and why should we rebuild on new foundations? To answer this question, we need to look at the philosophy of science. Now, this is a complex subject and a very complex story of which we will provide a sketch in this first portion of this lecture. Generally speaking, when something is functioning, we don't need to look at the engine. But when the car breaks down, then we need to open up the hood and see what's inside. And this is basically the situation we face currently, that statistics, econometrics, regression methodology, it is broken. It's not working. And therefore, we need to open up the engine and understand what went into the construction of this methodology, which has broken down, and how we can rebuild it. Rejection of religion in Europe led to the deification of science, that is, the belief that science was the only source of certain knowledge. Philosophy of science was created to prove that science led to certain knowledge and it was the only way to get there. Now, this attempt led to a disastrously wrong understanding of what science is. This misunderstood methodology of the physical sciences was applied to create a methodology for the social sciences in the early 20th century. And this methodology, because it is disastrously wrong, it led to a disastrously mistaken methodology for all of social sciences, and in particular for economics, econometrics, and statistics. This methodology currently in use cannot produce knowledge. And that's in a nutshell, the problem. In this lecture, we will provide a very brief summary of a very long and complex story. Starts with the import of science into Europe from Al-Andalus. When science came in, and then there were two separate disciplines. One was science itself, which developed fine and normally and naturally, but the other was the philosophy of science, which was the attempt to understand why science was such a great and superior methodology for the production of knowledge. But for reasons which have to do with the rejection of God, the philosophers of science could not understand how science worked, because basically science is based on the deduction of the unobservables, like atoms, from the observable phenomena, like Brownian motion. And now, since the philosophers of science wanted to deny the religion, so they could not understand this aspect of science, that how does it lead to understanding of the unknown by looking at the unknown. And once they rejected this basic founding principle of science, they could not succeed in understanding what science is all about. So to this day, there is this textbook, What is This Thing Called Science, which discusses a large number of different theories about what science is and comes to the conclusion that no one really knows. This misunderstanding of science has been applied to develop social sciences, and this methodology is the fundamental reason why statistics and econometrics are deeply flawed, and we need to rebuild the whole discipline on new foundations. So in this lecture, we'll try to explain what is the correct methodology of science and what are some of the common misunderstandings and how these misunderstandings have been applied to create econometrics and how we can fix these problems. The correct methodology of science was created by the first scientist, Ibn al-Haytham, and he had a very clear understanding of what he was doing. Ibn al-Haytham sought to reject conventional wisdom, and he said that we need to question received knowledge, and we submit it to argument and to examples and to demonstration, and not to the authority of the ancients. he was actually attacking Greek theories of science, which were extremely respectable, and it was very difficult to attack them because everybody thought that authority is what matters for truth. Ibn al-Hasan made major contributions to many fields of knowledge, analytic geometry, experimental psychology. He had a very sophisticated theory of vision. He had a lot of mathematical contributions, integration, conic sections, but his name is virtually unknown, and that is because of Islamophobia, extreme prejudice against allowing acknowledgement of contributions of the Islamic civilization. This has been documented in a book called Theft of History by Jack Goody, which shows that the Europeans took contributions from many civilizations and claimed them as their own, and invented European imitators who were labeled as creators of that discipline. One of the key things we need to understand is what is a scientific model, and the best illustration of this is by looking at the theory of vision as developed by Ibn al-Haytham himself. This illustrates what the reality of a scientific model is. Vision, or the process by which we see and understand external reality, is very complex as discovered by Ibn al-Haytham. So we see there is an external reality. There is this woman out there. The light comes from the object, and then it creates an image of that object, inverted image on our retina. This image is then processed by our brains, which uses not just the image but also our experience in dealing with the world in order to reconstruct an image of reality. So what a key insight of Haytham was that vision occurs in the brain, not in the eyes. So here's a schematic sketch. There is a complex reality out there. Of this reality we see some things. That's the observation. And then our mind processes this information to create an image of reality. So the mental model that we have in our mind, in our mind's eye, is a reconstruction of reality. It's not reality itself. So the image of reality that is created by our mind is different from the complex reality out there. Prior to Ibn al-Haytham, and even today, those who do not study vision have a very naive picture, which is called a philosophy of naive realism, which is that we directly observe the real world out there. This is actually wrong and is easy to see. If there is a tree out there, we have two images of this tree in our retina, and that is all we see. Our mind operates on the images on our retina. It does not have any access to the tree that is out there. So by looking at these two images formed on our retina, our mind reconstructs a picture of the tree as a mental image. So this is quite a different thing from what we think, how we think that our vision works. So from the two pictures on our retina, we recreate an image of the real world, which is very different from what our eyes are seeing. And this is what Ibn al-Haytham realized, that we see with our mind, not with our eyes. Our mind contains powerful computers which take the image and process it and create a picture of reality. In creating this picture, everything is involved: our heart, our experience, our emotions, and logic. But this powerful computer can also operate without any sensory input, and that is what we call, it can create pictures of perfection. It can create ideas like justice and beauty, and can think about mathematics in the abstract world. This is called the Platonic world of ideas. It can create pictures of alternative realities, what might be possible, even though nothing like that is currently seen in the world. So the mind has been given a lot of powers by God. This optical illusion operates by the power of our mind to seek perfection, and most people see a a correct phrase as opposed to the error that is actually in these signs, because they automatically correct the mistake that exists in the picture. So this shows the power of the normative ideal that our mind has to smooth the imperfect experience that we see in the real world. Optical illusions are created because we correct imperfect reality to the picture that we have in our minds. And so we know what things are supposed to be like, and we reinterpret the sensory input to make them conform to what they are supposed to be like. So there is this optical illusion created by building a house in which the floor is not really is slanted. So our eyes correct the slant of the floor and make it look like it is not slanted, and that results in everything else becoming slanted. Sociologist Max Weber argued that science is a uniquely European product because Europeans are uniquely able to think rationally. This ridiculous idea is currently widely accepted and believed, and it prevents the understanding that science was actually an import into Europe, and while Europeans understood science very well, they never managed to understand the methodology of science. And so we will briefly discuss this. The question of what is science has attracted a huge amount of discussion and controversy, but the reality is that science is simply a search for explanation. We see things that are puzzling and we try to find why these things happen. This is hardwired into us in the sense that our eyes see two inverted pictures of reality. We don't really see what is out there. And then our mind reconstructs what the reality is, which is producing these images inside our retina. So this reconstructed image of reality is the model of reality. And the key question in philosophy is, how does our reconstructed reality correspond to the actual reality? Some of the key insights from optics of Ibn al-Haytham is that the model in our mind is not the same as reality. This is what we think, that okay, the wall is blue and the floor is hard and the air is cool. But this is not a property of the objects outside us. The color that we see in the wall is created by a property that the wall absorbs certain frequencies and reflects certain others, and then the frequency that we see is coded into a color by our mind. So this color is not a property of the wall, it's a property of how we are built to see. So what we see is not exactly what is out there. Once we understand that the model of reality, the picture we have in our mind, is not the same as external reality, then two fundamental questions arise. What is actually out there? That's called ontology. And how do we learn about this? That's called epistemology. So one of the early approaches was to say that there are secondary qualities and primary qualities. This comes from ancient philosophy, that the color is a secondary quality. It doesn't necessarily belong to the object, but the shape, the mass, these are actually qualities of the object itself and don't have to do with the reconstruction in our mind. But this is just to illustrate the problems of knowledge and of ontology, what is out there and how to differentiate it from what we perceive. These are central issues which have been debated without any clear conclusion for centuries. The question of how our models, our mental models, match external reality is of central importance in philosophy. Unfortunately, in European intellectual tradition, many philosophers adopted what is called empiricism. And empiricism is an attitude that only the observations matter and the reality behind them does not matter. In particular, Kant was particularly influential in having this point of view widely accepted and adopted. And what Kant said was that, for example, when we see a tree, the actual object in external reality, there is a tree out there, but there is nothing we can know about it other than what we see of it. So the observation is the only thing which matters. And so our model, the mental image that we have of a tree, we don't need to check whether or not it matches the real tree in external reality. All we need to do is to ask how well the model that we have matches the observations that we see. And this is the basic problem of this is the basic philosophy called empiricism or positivism, which still dominates approach to science in West. Failure to understand science is reflected in this very popular textbook called What is this thing called science, which discusses a lot of different philosophies and comes to the conclusion that we don't really know the answer to this question. And basically the problems arise because of the failure, because of the empiricist approach, which says that models exist independently of reality and don't need to be cross-matched to reality. There are two further questions, that there is a misunderstanding of the scientific method, and then there is the issue that can we really apply the scientific method, whatever it is, from physics to the study of human societies? And the answer to both of these questions is negative. But social sciences are based on assuming a positive answer to both. That is, we know what the scientific method is and we can apply it. That's why social sciences are doubly mistaken based on foundations which are wrong on two different reasons. How all of this discussion matters for economics is built on Friedman's essay, which is on the methodology of positive economics, which is the most widely read essay on methodology by economists. And basically it says that the more inaccurate the assumptions, the better the model. We don't go into the reasoning for this, but basically it is a reflection of the positivist and nominalist methodology for science, which says that our model has nothing to do with reality. It needs to be consistent within itself, and it needs to match what we observe of reality. It doesn't need to go beneath to the underlying hidden unobservable reality which is generating the observations. And so our regression models look at the fit of the model to the data. They don't look at what is the reality which produced the data. And because of this lack of attention to hidden structures of reality, we produce terrible models and we never learn that they are bad. And so one of the essential and central elements, the job that we need to do in econometrics and statistics, is to study causality. But causality is inherently unobservable, which means our current methods are completely incapable of detecting what is the most important thing that a model needs to do. The impact of the Friedman essay has been that economists work in this special way. They take a situation in the real world, then they translate it into an artificial world in which there are only these strange people called Homo economicus who only look at profits and utility, and they're not like real human beings. Then, but because they are basically rational robots, you can calculate what they do. So the economist can calculate what will happen in this artificial world, and then they say that, okay, this is what will happen in the real world. But there is no justification. The model is completely artificial and completely useless in terms of understanding what the real world is and why it works like it. But because of this divorce between models and reality, the economists use these artificial models and then they use them to predict what will happen in the real world. Similarly, statistics is founded on a false artificial assumption that take any data set, it must come from a hypothetical imaginary infinite population which has only a few parameters. This assumption has no basis, no justification in reality. It's just a model. But because models don't have to match reality, we are supposedly allowed or free to make such an assumption. And then we calculate the parameters of this imaginary distribution, and then we pretend that the data actually is a sample and use this pretend model to make calculations about the real world. In a similar way, econometrics deals with regression models, and these are when you have multiple data series, not just one, and then you're looking for the relationships. So the way it proceeds is that you choose one variable that you want to explain, you imagine the causes of these variables without having any evidence about this, and so then you imagine that there is a linear relationship between your dependent variables and independent variables, and you add an error term to fix any discrepancies in linear relationship. And then you make assumptions about error. These are part of your model. You make assumptions about the errors, you make assumptions about the causal relationships. And now, having made these assumptions, these are part of the model, we don't worry whether these assumptions are right or wrong, because the model doesn't have to be true. So we just make calculations according to the model, and then we assess whether or not our calculations give reasonable, good results. So this is a very disastrously wrong methodology, which leads to disastrously wrong results.